All right, today we are going to be going over negative exponents. So let's start by writing our I can statement. I can evaluate negative exponents. I can evaluate negative exponents. And hopefully you learned from class today in Mr. Dudek's and Mrs. Pritchard's class activity, you learned that when you have a power, and I'm just going to give one of the group's example, 2 to the 8th power ended up being 2 times 2 times 2 times 2 times 2, which ended up being 16. 2 to the 3rd power is 8. 2 to the 2nd is 4. 2 to the 1st power is 2. 2 to the 0 power is 1. And we did this last week to prove that anything to the 0 power is 1. Well, notice our powers or our exponents decreased. This continues when we do our negative exponents. So, to remind you of what you learned in class today, you can take what was in standard form and divide it by the base. So 16 divided by 2 ended up giving us our 8. 8 divided by 2 ended up giving us our 4. 4 divided by 2 ended up giving us our 2. 2 divided by 2 ended up giving us 1. So don't stop there. We still keep going. 1 divided by 2 is 0.5, or we can write it as 1/2. What is 1/2 divided by 2? It would be, think 1/2 divided by 2. You change you remember, keep, change, flip. You keep the first fraction, change division to multiplication, flip the second one. So 1/2 times 1/2 is 1/4. Hopefully you are noticing a pattern here that the exponent 1, you have 2 to the 1st, 2 to the negative 1st. You have a 2 and a 2. It's just the placement of that 2. Here you have 2 to the 2nd, which is 4. 2 to the 2nd is, or negative 2nd is 1/4. So if we know 2 to the 3rd is 8, 2 to the negative 3rd is 1/8. So when you have a negative exponent, it is going to be a fraction. It is not going to be a negative value. It is just going to be a smaller number. So let's write the algebraic rule for this. For any non-zero number x, and integer a, x to the negative a power equals 1 over x to the a. And I'm sure some of you are still a little bit confused on this, so I'm going to show you what I need to show you to understand exponents, positive and negative exponents. I'll give you a minute to write that down. Again, if you need to pause the video at any time, pause the video. Unfortunately, if you're in class right now, you can't pause me. All right, I'm going to continue on. I like to think of positive exponents as happy exponents because positive people are happy. So positive exponents are happy exponents. Therefore, negative exponents are unhappy. They're sad, they're mad, they're negative. Well, there's a reason why they are unhappy or negative, and I'm going to show you why. If you have an example, x to the 3rd over x to the 7th. Well, we learned the other day that if you are dividing two things with the same base, you subtract your exponents. So theoretically, this would be x to the 3 minus 7 or x to the negative 4th power. Well, the reason why that is x to the negative 4th power is this. You really have 3 x's at the top and 7 at the bottom. Then you should be thinking to yourself, okay, how many of these cancel? Well, x goes into x once, X goes into X once, X goes into X once. So we're left with 1 in the numerator, because 1 times 1 times 1 is 1. And what are we left in the denominator? X to the 4th power. Notice that exponent is happy. Why is it happy? Because that's where they were left over. That's where they belong. But notice up here it's x to the negative 4th. Well, the reason why it's x to the negative 4th is because that's like saying x to the negative 4th over 1. Were the x's really truly left in the numerator? No. Where do they belong? They belong in the denominator. So when the x's are where they belong, they're happy, they're positive. So when your negative exponent is in the numerator, it's saying, all right, I'm negative, I'm unhappy up here. Yeah, there's 4 of me, but I'm negative because I really don't belong in the numerator. I really, truly belong in the denominator. So if you wanted to make this positive and make them happy, you would take x to the 4th and you would simply put it at the bottom, because that's where they truly belong. And you would make sure you keep a 1 up at the top. And isn't that what we got down here? So x to the negative 4th is the same thing as 1 over x to the 4th. This is just, they're unhappy where they are because they don't really belong there. Here, they are happy because that's where they belong. All right, so let's do a couple more examples of positive and negative exponents, happy and sad exponents. So let me bring up another page, go over some more examples. Let's do 4 to the negative 3rd power. 4 to the negative 3rd power, notice this is a negative exponent. So therefore, it is sad. Why is it sad? Because the 4's really do not belong in the numerator. Where do the 4's really belong? They belong in the denominator. So put those 4's where they truly belong and make them happy. Notice I didn't do anything with the exponent other than got rid of my negative. My negative simply tells me that that's not where they belong, okay? Positive is saying, hey, I'm happy here because this is where I belong. And what do we put in the denominator when there's nothing else there? A 1. So this is really 1 over 4 to the 3rd power. Or if I asked you to write this in standard form, it would be 1 over 4 times 4 times 4, which is 1 over 64. All right, let's do another one. What if I give you negative 4 to the 0 power? Might be a tricky one, but I don't want it to be, because just because this negative, I don't want you to think there's a negative exponent. This negative in front of the 4 has nothing to do with the exponent. So I kind of threw a trick problem in here, because you should know anything to the 0 power is, you should be saying to yourself right now in your head, 1. All right, let's go over another one. Let's do, let's figure out 5 to the 5th power over 5 to the 8th power. Well, by knowing your rule, that when you are dividing two things with the same base, you keep the base and you subtract your exponents. So I would do 5 minus 8. Well, 5 minus 8, if you need to help you out and get this correct, you do bam bam. So then you end up with 5 to the negative 3rd power. Well, if I don't want you to write this as a negative exponent and I want all exponents to be happy, you would think to yourself, oh, Mrs. Pritchard, that 5 to the negative 3rd doesn't really belong there. It really belongs in the denominator. So you put 5 to the 3rd down there, and what do we put up in the numerator? We put a 1. And if I asked you to evaluate this, remember it would be 1 over 5 times 5 times 5, which is 1 over 125. And those of you who may need to see this written out, if you don't need to, you can kind of fast forward me through this. But those of you who might need to see why this works, again, here we have 5 5's in the numerator. We have 8 5's in the denominator. Okay, so now if I were to simplify, just like I were simplifying any fraction, I notice, oh, there's a 5 and a 5 they have in common. 5 goes into 5 once, 5 goes into 5 once, 5 goes into 5 once, 5 goes into 5 once. So what do I have left over? I have 3 5's left over. So that would be 5 to the 3rd power. And what do I have in the numerator? 1 times 1 times 1 times 1 times 1, which is 1. So I have 1 over 5 to the third. Notice the 3 is happy. It's positive because that's where they belong. But if you do it by the rule, it ends up being negative. It's still correct because 5 to the negative third power is 1 over 5 to the third. Just make sure you understand and you know what the direction is asking. Sometimes the directions ask you to just simplify, and it doesn't matter if the exponent's positive or negative, but sometimes it asks you using only positive exponents. I want to go over one more example, and then we will be done. All right, what if I give you, whoops, I duplicated the page instead of giving you a new problem. All right, what if I give you 4 to the negative second power times 1? If you will notice this problem, first we have 4 to the negative second power, so automatically you should think in your head, I need to make that exponent happy. So 4 to the negative second power would be 1 over 4 squared, which is 1 over 16. Well, 4 to the second, or negative second power is 1 over 16 times then our 1. Well, what is 1/16 times 1? 1/16. And let's do one more. 4 to the third power to the fourth power times 4 to the negative second times 3 to the 0 power. And let's simplify this. Now we're kind of using all of our rules. First, when you raise a power to a power, you multiply your exponents. So this is 4 to the 3 times 4, or 12th power, times 4 to the negative second power is 1 over 16, or I'm just going to write 1 over 4 squared, times 3 to the 0 power is 1. So now I'm going to notice that I have 4 to the 12th times 1 is 4 to the 12th over 4 to the second power. Well, remember, when you're dividing two things with the same base, you subtract your exponents. So I don't know why I just wrote a 10. Well, I know why I wrote a 10, but I did it too fast. Okay, so you keep the base and you subtract your exponents. 12 minus 2, so it's 4 to the 10th power. All right, what I would like you to do now is below the link on the video is a link for a Google form, and I need you to complete those problems, whether you have Mr. Dudek or myself, so that we know whether you understand the notes or not. Thank you very much. Let me see. What?